Welcome to the channel. Coming to the solution of this problem, what they ask in this circuit, output voltage is triangular wave, and what we have to find out, the input voltage nature. I'm drawing the same circuit here. The first operational amplifier is in open loop configuration. This is negative terminal, this is positive terminal. So simply this is comparator. Two resistors are here, and this is Zener diode connecting it to ground. Then input to the second coming operational amplifier is applied to the inverting terminal, feedback capacitor. The output voltage nature is given here, and which is triangular wave. In the same output voltage is applied to the resistor at the non-inverting terminal of the comparator, and we have to find out this input voltage, say Vi. And the positive terminal of the second op amp is connected to the ground. The second circuit based on operational amplifier is simply integrator. The first op amp is in open loop configuration, that is comparator. I have explained in previous videos comparators and integrators in details. I am providing the links in the description box. Coming to the solution, as we know that the output of the comparator is always square wave, plus V saturation minus V saturation. So in this case, so this is plus V saturation, maximum voltage, which is the supply voltage of the operational amplifier, and we call it as plus V saturation, and this is minus V saturation. The comparator output is a square wave, and this square wave is applied to the inverting terminal of the integrator. We know the formula of the integrator. Before that, say this is 0 and this is t. Say this is 0 and this is t. So I am considering in general total cycle, which includes one positive half cycle and one negative half cycle. So what is the output voltage of integrator, which is equal to minus 1 by RC, integration from 0 to t, input to the integrator. I mean to say input voltage to integrator, I am considering say P dt, and after solving what I am getting, minus V by RC into T, and this is the output voltage of the integrator. In general, I have considered over one complete cycle from 0 to t, and after solving what I am getting, minus V by RC into T. Say this is equation 1. So from equation 1, if the input to the integrator is at inverting terminal, and which is a square wave coming from the comparator, so plus V saturation, if you are going to put the value here, plus V saturation, so what we are getting, minus V saturation by RC into T, for example. So this is like a ramp signal. So what we are getting here, so during positive half cycle, the input to the inverting terminal of the integrator is plus V saturation, and if you put this value, what we are getting, minus V saturation by RC, and it is like a ramp signal, and we are getting a decreasing ramp. Positive half cycle, we are getting decreasing ramp. What will happen during negative half cycle? The input to the inverting terminal is minus V saturation. So minus V saturation and this minus V saturation will become positive, and we are getting increasing ramp signal, and then again decreasing ramp signal. Likewise, we are getting the triangular wave at the output of this integrator, and this triangular wave we are applying through this resistor at the non-inverting terminal of the comparator. So this is open loop configuration of the operational amplifier, so simply comparators, and we are getting the triangular wave at this non-inverting terminal of the op amp. So what will be the input to this comparator? So in the comparator, we need the reference voltage to compare with the other terminal. So here non-inverting terminal is triangular wave, and we need DC reference voltage. So the reference voltage is always DC, and we need the reference voltage to compare this triangular wave, so that that square wave will be generated, the output of this comparator, and this input voltage is nothing but the reference voltage, and reference voltage is DC voltage. So out of these four options, the first option is right. So input not square triangular, and trigger is also a pulse. So the right option is A, that is grounded, and this is the solution of this problem. If input voltage is grounded, then the triangular wave will be compared with this ground reference line, and accordingly we are getting the square wave at the output of the comparator, and this square wave we are applying at the input of the integrators, and we are getting the triangular wave at the output. So grounded is the option at the input side. Thank you.